Every day, hundreds of millions of us start our morning with the simple act of washing our hair. That familiar bottle, the rich lather, the clean feeling, it's a ritual we perform almost on autopilot. But have you ever stopped to think about the journey that bottle of shampoo takes to get to your shower? What does it really take to create a product used by billions? Today, we're not just looking inside a factory. We're pulling back the curtain on a world of colossal machinery, precise chemistry, and mind-boggling scale. We are entering a mega factory that transforms thousands of gallons of raw materials into hundreds of thousands of bottles of shampoo every single day. This isn't just a story about soap and water. It's a story of industrial science, robotic precision, and the hidden world behind one of the most common items in your home. Welcome to the heart of the personal care industry. In this sprawling facility, the air hums with synchronized machinery, and the scent of carefully crafted fragrances hangs in the air. This is where the magic of mass production meets the science of cosmetic chemistry. The journey from a pile of powders and a vat of oils to the finished, sealed bottle of shampoo on a store shelf is a symphony of automated processes, each one fine-tuned for maximum efficiency and perfect consistency. So, stick with us as we go step by step through this entire process. We'll follow the raw ingredients from the moment they arrive. Watch their transformation inside colossal steel tanks. Understand the science that makes every bottle perfect, and see how an army of robots prepares the final product for its journey to you. We'll uncover the secrets to getting that perfect texture and the rigorous testing that guarantees every single bottle is safe. This is the complete story of how shampoo is made. Chapter 1. The foundation, raw materials, and purity. Every great creation starts with the right ingredients, and for shampoo, that process begins with the most fundamental ingredient of all: water. Water is the backbone of any shampoo, often making up 70 to 80% of the final product. But this isn't just tap water. It has to be purified to an almost pharmaceutical grade, completely free of minerals or microbes that could mess with the shampoo's formula or shelf life. To get it this pure, the factory uses a high-tech water treatment system built around a process called reverse osmosis. City water is forced under incredible pressure through a series of special membranes. These membranes act like microscopic bouncers, letting pure water molecules through while blocking almost everything else. The deionized water that comes out is so pure it's a blank canvas, ensuring the shampoo's performance is decided only by the ingredients added on purpose. Without this pure water, consistency across millions of bottles would be impossible. While that water waits in enormous storage tanks, the other ingredients are getting ready. They arrive in staggering quantities. Powders in super sacks that weigh thousands of pounds and liquids in huge tanker trucks. They're all meticulously catalogued and stored in a vast, climate-controlled warehouse, a library of the building blocks of hair care. The most important of these are the surfactants. These are the workhorses of the shampoo, the ingredients that actually do the cleaning. Surfactant molecules have a clever two-part design. One end loves water, and the other end loves oil and dirt. When you lather up, the oil-loving ends grab onto all the gunk in your hair, and the water-loving ends hold on to the water, letting you rinse everything away. The primary surfactants, like sodium lauryl sulfate, SLS, or sodium laureth sulfate, SLES, are great at cleaning and creating that classic foamy lather. But a shampoo with only those primary surfactants would be too harsh. So, a blend of secondary surfactants is added to soften things up. Milder ones like cocamidopropylbutane help create those rich, dense bubbles that we all associate with a quality product. Next up are conditioning agents. These are what separate a basic soap from a real hair care product. They counteract any harshness, leaving hair feeling soft and smooth. This can include silicones like dimethicone, which form a thin, shiny layer over the hair to reduce frizz. It can also include cationic polymers that are drawn to damaged spots on your hair, helping to smooth the surface and cut down on static. To make sure the shampoo stays fresh and safe on its journey to your bathroom, preservatives are essential. A water-based product like shampoo is a perfect breeding ground for bacteria and mold, so a tiny but critical amount of preservatives like phenoxyethanol or sodium benzoate is added to stop anything from growing. Finally, there are the ingredients that create the whole vibe of the shampoo. Thickeners, like simple sodium chloride, table salt, or natural gums, are used to get that rich, honey-like consistency. Without them, the shampoo would be a runny mess. Then come the fragrances and colors, which are key for brand identity and user experience. At this stage, special active ingredients are also added to tackle specific issues like dandruff or to promote hair growth, turning a general shampoo into a targeted treatment. Each of these ingredients is tested and approved by the quality control lab before it even gets near the production floor. Chapter 2. The heart of the factory. The mixing process. Once all the raw materials get the green light from quality control, they're ready for the most important phase. Mixing. This is where separate ingredients start to become one single, uniform product. The center of this whole operation is a series of massive stainless steel mixing tanks. These things are engineering marvels, some holding thousands of gallons, enough for tens of thousands of bottles in just one batch. These tanks are built from the same super hygienic grade of stainless steel you'd find in surgical equipment. They have a double wall or jacket for heating and cooling, which gives operators precise temperature control, a huge deal since some ingredients need heat to dissolve, while others are heat sensitive. The process kicks off when the factory's central computer system calls for a new batch. Following a digital recipe, automated valves open, and the perfect amount of purified water is pumped into the tank. The water is often preheated to around 130 to 140 degrees Fahrenheit, 55-60 degrees, to help dissolve the powders and waxes that are coming next. The mixing itself is done by a powerful agitator. This isn't just a simple propeller, it's a complex system of blades designed to keep the entire tank in constant motion, getting rid of any dead zones where ingredients could settle. Some mixers even have an outer blade that scrapes the tank walls to keep anything from sticking, while a faster central blade creates a powerful mixing vortex. The order of ingredients is a carefully choreographed dance. Primary surfactants usually go in first. If you just dump them in, they'd form stubborn clumps, so they're often sprinkled in slowly or sucked in through a port below the liquid surface, letting them dissolve evenly. Once the base is uniform, the other ingredients follow: secondary surfactants, conditioning agents, and thickeners. All the while, the steady stirring and controlled temperature make sure everything blends together seamlessly. One of the biggest enemies here is air. Whipping too much air into the mix would create a tank full of foam instead of a dense liquid, messing up volume measurements and making the product unstable. To prevent this, many tanks operate under a vacuum, which sucks the air out of the tank, stops foam from forming, and even helps pull powdered ingredients in more efficiently. This whole mixing dance can take several hours. Throughout, automated sensors are constantly tracking the temperature, viscosity, and clarity. The goal is to create a perfectly uniform liquid, known as the pre-mix, ready for the next step. Chapter 3. Achieving perfection, homogenization, and refining. The shampoo is now all mixed, but it doesn't have that perfectly smooth, creamy texture just yet. If you left it like this, oils and silicones might eventually separate, and the feel could be uneven. To get that flawless consistency and ensure it stays stable for years on a shelf, The batch has to go through a process of intense refinement called homogenization. The mix is pumped from the main tank to a homogenizer. This machine is designed to put the liquid under extreme force, breaking down particles and droplets to a microscopic size so they can never separate. One of the most common types is a rotor-stator mixer. The shampoo is sucked into a workhead where a central rotor spins at thousands of RPM inside a stationary outer casing called the stator. Centrifugal force flings the product outwards at incredible speed, forcing it through tiny slots in the stator. This intense mechanical shear pulverizes any suspended droplets of oil or silicone into micron-sized particles, creating a stable emulsion where everything is permanently blended. It also gets rid of any last clumps of powder, leaving a perfectly smooth liquid. After this intense workout, the shampoo is almost done. The batch is slowly cooled down, and the most delicate ingredients are added. Heat-sensitive things like vitamins, botanical extracts, and, most importantly, the fragrance go in now. Adding the fragrance at a lower temperature keeps its scent from breaking down. Next comes a critical pH adjustment. The natural pH of your hair and scalp is slightly acidic, typically between 4.5 and 5.5. A shampoo that's too alkaline can lift the hair's outer layer, or cuticle, causing frizz and damage. To prevent this, technicians test the batch's pH and slowly add a mild acid, like citric acid, to get it perfectly balanced within that target range. The final touch is adjusting the viscosity. A sample is tested with a viscometer, which measures how thick the liquid is. If the shampoo is too thin, a small amount of a thickening agent, often a simple salt solution, is added. The salt ions interact with the surfactant molecules, causing them to arrange in a way that thickens the product into that final, rich texture. Now the bulk shampoo is officially complete and gets transferred to a holding tank, ready for its final exam. Chapter 4. The Gatekeepers. Rigorous quality control. Before a single drop gets cleared for bottling, it must pass through the factory's toughest department, quality control. This lab is the nerve center for product safety and consistency, staffed by technicians whose only job is to be the final gatekeepers. Samples are taken from the holding tank and put through a whole battery of tests. First, the physical properties are checked. The pH is measured one last time to make sure it's in that hair-friendly range. The viscosity is rechecked to guarantee the shampoo has the exact thickness consumers expect. A sample is visually inspected for the correct color and clarity. If it's a pearlescent formula, they check for the right amount of shimmer, which comes from an ingredient like glycol distearate. Next, they test its performance. A key test is for foam. A standard amount of shampoo is mixed with water and shaken. They measure the initial foam volume and then measure it again after a few minutes to ensure it produces a rich, stable lather. A major sign of quality for most people. The chemical composition is also verified. Using advanced analytical techniques like spectroscopy or chromatography, the lab can quickly confirm that key active ingredients are present at the correct concentrations. The fragrance is also sniffed by a trained sensory panel to ensure it perfectly matches the standard for that product. But maybe the most critical test is for microbiological safety. A sample is put on a petri dish and incubated for several days to see if any bacteria or fungi grow. Thanks to the purified water and preservatives, contamination is incredibly rare, but this is a non-negotiable safety check to ensure the product is 100% safe. Finally, stability testing is done. Samples are put in ovens and refrigerators to simulate aging in different climates. Technicians check them over time for any changes in color, texture, or pH. This ensures the shampoo will stay perfect throughout its entire shelf life. Only when a batch passes every single one of these tests does QC give its approval. A green light flashes in the system, and thousands of gallons of perfect shampoo are released to the packaging line. Chapter 5. The final sprint, filling and capping. With the shampoo officially approved, it's ready for the high-speed sprint to become a finished product. This all happens on the automated filling and packaging line. The process starts with the bottles, which are often made right here in the factory. Tiny plastic pellets are melted down and forced into a hollow tube called a parison. This hot, soft tube is then captured in a bottle-shaped mold, and a jet of compressed air inflates it, forcing the plastic into the shape of the bottle. The mold cools, the bottle solidifies, and out it pops, ready for filling. The empty bottles are fed onto a conveyor and sorted by a machine called an unscrambler, which makes sure they're all standing upright and facing the same way. Then, they march in single file toward the filler. The rotary filling machine is fed shampoo directly from the holding tanks. As bottles move into position under the filling nozzles, they're filled with incredible precision. For a thick product like shampoo, piston fillers are often used. A piston pulls back, drawing a precise volume of shampoo into a cylinder, then pushes it out into the bottle. To avoid a foamy mess during this high-speed fill, the nozzles often use a bottom-up technique. The nozzle goes down into the bottle and starts dispensing as it slowly rises, keeping the tip just below the surface of the liquid. These machines can have dozens of nozzles working at once, filling hundreds of bottles per minute with pinpoint accuracy. Immediately after filling, the bottles head to the capper. Caps are fed from a hopper, placed on the bottles, and then tightened to a precise torque, secure enough to prevent leaks, but not so tight you can't open it. Whether it's a screw cap, a flip top, or a pump, the process is fully automated and relentlessly efficient. Chapter 6. The finishing touches. Labeling and packaging. Filled and capped. The bottles are almost there, but they're still anonymous. The next step is labeling, where they finally get their identity. The bottles continue their march along the conveyor to a high-speed labeling machine. For the common wraparound labels, a pressure-sensitive system is used. As a bottle spins past the labeling head, a sensor triggers, and a label is applied and smoothly wrapped around the surface. A soft roller presses it down to make sure there are no bubbles or wrinkles, but these labels hold more than just the brand name. An integrated printer adds a unique batch code and expiration date to each bottle. This code is the product's fingerprint, linking it back to the exact production batch, the raw materials used, and all of its quality control data. After labeling, the bottles pass through a final automated inspection. High-speed cameras and smart software check that the fill level is correct, the cap is sealed properly, and the label is on straight. Any bottle that fails this check is instantly kicked off the line by a puff of air or a robotic arm. Only perfect products move on. The finished bottles are now ready for shipping. They're grouped together, and a robotic packer gently picks them up and places them into a freshly assembled cardboard box. The box is sealed, labeled with its own shipping barcode, and sent to the palletizer. This large robot arm stacks the boxes onto a wooden pallet in a stable, interlocking pattern. Finally, the entire pallet is stretch-wrapped, creating a secure, shippable unit, ready to be sent to distribution centers, stores, and ultimately, to you. Chapter 7. The Unseen Hero, Automation and Efficiency. Watching this whole process reveals the true hero of the mega factory, automation. Every single stage is connected and controlled by a sophisticated system of machines, sensors, and computers. This seamless automation is what makes this incredible output possible, producing millions of bottles with a consistency that manual labor could never achieve. The production line acts like a single organism. The conveyor speed is perfectly synchronized with the fillers and cappers. If one machine slows down, the whole line can adjust its pace to prevent a jam. This maximizes what they call throughput, the key to success in high-volume manufacturing. Automation drives huge efficiency gains. Automated mixing eliminates human error. High-speed filling minimizes waste. Robotic packers work 24/7 at a speed and precision no human can match, all while improving safety by handling the repetitive, strenuous tasks. Underpinning everything is an absolute commitment to hygiene. All equipment that touches the product is made of high-grade, mirror-polished stainless steel to prevent anything from sticking and make cleaning easy. And they don't scrub these giant tanks by hand. They use an automated clean-in-place, or CIP, system. After a run, the factory's computer initiates a cleaning cycle. A series of cleaning and sanitizing solutions are automatically flushed through all the tanks and pipes, controlled for temperature and flow rate, ensuring every surface is sterile without a single person ever having to go inside. This combination of smart automation and relentless hygiene is what turns the art of cosmetic chemistry into the science of industrial production, ensuring that the millionth bottle of shampoo is just as perfect as the first. The scale of this operation is truly breathtaking, a perfect blend of chemistry and engineering just to create an everyday product. What part of this massive process did you find most fascinating? Was it the microscopic water purification, the intense power of the homogenizer, or the robotic ballet on the packaging line? Let us know in the comments below. And if you enjoyed this look inside the hidden world of manufacturing, be sure to like this video and subscribe for more deep dives into how the things that surround us are really made. So, the next time you step into the shower and reach for that bottle, take a second. Think about the journey it took. Remember the colossal, gleaming steel, tanks where ingredients were blended with scientific precision. Picture the incredible forces that created that perfectly smooth texture. Imagine the army of silent, tireless robots that filled, capped, and packed it at lightning speed. And don't forget the vigilant technicians in the lab, the guardians of quality who made sure the product in your hand is safe and effective. The simple act of washing your hair is the final step in an immense story of scale and complexity. It's a story that starts with tanker trucks of raw materials and ends with a single bottle in your bathroom. This mega factory, a symphony of chemistry, engineering, and automation, shows us the incredible industrial world that powers our daily lives. From a 1,000-gallon batch to a single satisfying lather, this is how shampoo is made.